Hey there, so today we're going to learn how to build a procedural particle spawner in Unreal Engine 5. Let's go. So we're inside Unreal Engine. First, let's see what we'll get at the end of the tutorial. So as you can see, there is dust spawning in front of the camera. And as the player moves, the dust is also spawned at a different location. The frequency of the spawning follows a certain rate, but there is some random deviation happening so that it is not too predictable. So that's pretty much it. Now let's see how we can build that. Before starting, I just want to say that I'm using some assets. Here they are. It's mainly 3 textures. One particle system is the red dust that we've seen earlier, and a material for the dust. I'm going to put them in the description below, so get them if you want. I've also created a micro library, but we'll see its usage later in the tutorial. So now we can create the blueprint actor, and we'll call this procedural dust spawner, and with a VP at the start. First thing that we're going to do is to create a box component, this one, and we're going to use that to define the bounds in which the particle will be spawned. We'll see that a little bit later, it will be more clear, I think. So let's go straight into the event graph and create a new custom event. Oops, sorry. And we're going to call it enable. And in this one we are just going to set timer by event. There we go. And we're going to create a new custom event, and it will be the event that will spawn the particles. So in this case we're going to call it spawn the trail. For now we are going to put the time, let's say, at 1, but we will change that later on, so it's just temporary. So for now we are going to set the time at 1. It means that this event will be called 1 second after this set timer by event is called, but it's only temporary. And this spawn trail event will be the one called each time we are spawning a particle. So first we're going to set the actor location, so that each time we spawn a particle, this actor takes the same location as the player, because in this one we're going to spawn particles around the player. If you want to spawn particles around another character, you just have to change the actor you're using there. In our case we're going to take the player, and we're going to call the get actor location, and we're going to set the spawner location at the player location. Then we need to get a component from the player, and we're going to use this component by class function, and it just returns the component if it is present. If it is not, we are going to get a null value. So we're just going to check if it is valid. With the player it should always be valid, but just in case. Let's clean that a little bit. Now we just need to find a location where we'll spawn the particles. For that we're going to make a loop. So we could use a while, but in this case it is better to use a do while, but the do while does not exist in Blueprint by default. So what I did is that I've created the do while function in the macro library. It is like that. It can be a little bit confusing at first when we see it like that, but in fact it's quite straightforward. First we're going to execute the loop body, because in a do while we execute the first loop before checking the condition. So there we execute the first loop, and then we check the condition. If the condition is true we can complete, and if it is false we go back to the sequence and we execute a second loop, and then we recheck the condition, and we do that until the condition is met. So we need to be sure that the condition will be met, otherwise we will have an infinite loop. So there we're going to use this do while macro, and by the way all the function declare, or rather the macro declared in a micro library are globally accessible. So that's why we can call them like that. And here in the loop, we want to find a location within the bound of this box component. So I forgot to do it, but we can set the bound of the box. I've tried some different values and 500 is fine, but you can tweak it as you want. So here we want to find a location within those bounds. So we are going to create a new function that we are going to call getRandomLocation. And what we want to get is, of course, a location. It is a vector. So as I said, we're going to take this box and we're going to call the random point inbounding box, this one. So we need to provide a center location and an half size. The half size is just the extent of the box that we have just set previously, so this one. So there we can get the world location of the box as the center, and for the half size we can get the scaled box extent. So here, if you've seen, we had the choice between unscaled and scaled. So the scaled box extent will take into consideration if you modify the scale over there. So here we've kept the scale by default, so it doesn't matter. But if you modify this one and you want to take it into consideration within for the extent, you should use this one, the scaled one. But by default, it's always better to use the scaled one. So we can return directly this location. But we also have to do another thing. So we need to find a way to know that this location is in front of the camera. For that, let's take a little schema to explain things a little bit. So let's say that we've got our player over there, and this is the random location that has been returned, and this is the camera angle. So here the point is in the camera view. So what we're going to do is to compute this direction, the lookat rotation between the player and the random location, and we're going to calculate the dot product between this rotation, or this direction rather, and the forward vector of the camera, and the camera is pointing toward there. So we're going to compute the dot product between those two directions, and then we just need to check that the value of this dot product is above a certain value. In our case, we're going to take 0.6. That's pretty much what we are going to do. So going back to Unreal Engine, we're going to get our player character and get the camera component by class in the same way as we did earlier. And as explained in the schema, we are going to take the forward vector of the camera and we're going to compute the dot product between this direction and the lookat direction between the player and the random location. So for that we need to get the actual location of the player, and we're going to use the find lookat rotation node between the start location of the player and the random location, and we're going to take the x direction from that. And now we can compute the dot product between the two. And we're going to return a second value, and this will be the dot product. There we go. So going back to our event, now in the loop body, we can get a random location. And we're going to exit the loop if this dot product is above or equal to 0.6, which means that this location is in front of the camera, and we're going to fit that in the condition value. So this is working fine, and we can do a line trace once we have found our location. but we can imagine some case where we can't find the location and the loop will be infinite. So in this case, we can create a limit using a counter. So we just need to increment this counter at each loop using this node. And we're going to add a new condition. So now we are going to exit the loop if the location is valid, or if our counter is above a certain value. We can take a value something like 30, that will be fine. So we want to check that the count, if the count is above 30, we will exit the loop and we will take the last random location, even though it's not in camera view. But you can put a higher value if you want it to loop longer. It really depends on your use cases. So now we've got our random location. First of all, we can set the counter and reset it to 0 for the next time. And now we can do a line trace where we will find the location where our particle will be spawned. We're going to split this value and take the random location that we have found and break it. Because what we want to do is take the x and the y from the random location. But for the z, we're going to take the player location, split it, and we're going to take the z value of the player and we're going to add an offset. Something like 1000 works fine usually. And we're going to fit that into the start z. And for the end, we're going to take the same x and y, but we're going to take a reverse offset so that it's tracing from up to down and next to the player location. So we're going to put that at 4 duration just to see how the trace is done. And now we can break this hit result and we can spawn our emitter at the hit location, which is this one. And let's take our dust trail. So that should be working, but we want to spawn the particle frequently. So we need to take the exec pin and go back to where we define the timer event, so that we plan another execution of this event. Let's clean that a bit, like so. And for the time, as I've said, we're going to modify this. So let's say that by default we want something like 2 seconds between each spawn. So we're going to create a value time between spawn. It will be a float. And we're going to take, and we're going to put 2 seconds. So let's take this one. But we also want to add random offset between the spawns, so it does not spawn each time at the same frequency. We want to add a little bit randomness. So for that we are going to use the random float in range. And it will be between this -2 or this +2. So this means that our time delay will be between 0 and 4 seconds. Now we just need to call the enable event at begin play, so that the first set timer is called. And now we can see if it works. Let's put the blueprint in our level and let's start playing. So there is a time, there we go. The first trace is air, and now there is new particle spawning frequently. So as you can see, the trace is going from there down to the ground, and as we move, the particles will always be spawned in front of the camera. So you can adjust the time value if you want the spawn to be more frequent or less frequent depending on your use cases. And you can also change the particle system if you want to spawn something else. But it's working fine, and we're done. So that's it for this tutorial, hope you enjoyed it. And like always, you can thumbs up, subscribe and share to help me out. And this is it. So see you another time, bye.